So now the third part of this question is basically we want to find the probability of that basically only one of them will pass the test. The probability that only one of them will pass the test. So now in order to calculate that, only one of them will pass the test means that basically that means that either one of them basically either one passes the test and the other doesn't, and the other way around, meaning that either for example here we said that Anil will pass the test and F was Ashima will pass the test. Now when we say that when we say that only one of them will pass the test, that means that either E occurs and then basically the event E occurs and then in conjunction with that also F prime occurs, or basically what could happen also is that basically F occurs and then in conjunction with that basically E prime occurs, meaning that either Anil will pass the test and Ashima will lose, or not lose of course, will not pass the course basically, or pass the test, or Ashima will pass the test and then Anil will not pass the test. So now in order to basically write that mathematically, what we need to do is that the event only one of them will qualify the examination is the same as the event either Anil will qualify and Ashima will not qualify, or Anil will not qualify and Ashima will qualify. So we can basically write it this way. So the event only one of them will qualify the examination. So if I say only one of them will pass the test, what that means is that I can rewrite this expression as basically is the same as the event. I can rewrite this as basically either is the same thing as either Anil will qualify, Anil will pass the test, and Ashima will not pass the test. Okay? So either this or basically Anil will not pass, and Ashima will pass, right? Ashima will pass. So I can write it this way, right? Now, that means basically this is so you have two statements basically with the connective or. And so then when we say that Anil will pass the test, that would be basically E, that would be basically E, and F would be Ashima will pass the test, right? So for this part of the statement, Anil will pass, is basically E, and then when I use an AND over here, so we need to look this up. So we said that basically A and B that we wrote as okay, so we need to go back and take a look at these two connectives here. Okay, so we had an event here. First of all, it's basically we had the complementary events, we already talked about them. And then the second thing that we had here was basically the event A or B, right? Let me write it down over here. So we had the event A or B, right? So the event A or B, we said that basically the union of two sets A and B, denoted by A union B, contains all the elements of are either in A or in B or in both. Meaning that if you have two sets over here, so for example, if you have A over here and B over here, then A union B is basically, what that means basically in terms of a Venn diagram is basically all of the elements that you can find in A and all of the elements that you can find in B, and there is also these elements that you can find in both, but then these elements that the two sets have in common, you don't repeat them. Meaning that suppose that, for example, A is, for example, 1, 2, 3, and 4. And B is, for example, 5, 6, and 3, and 4. Then A union B would be equal to basically, would be 1, 2, 5, 6, 3, and 4. So as you can see, 3 and 4 is basically does exist here, and it does exist here as well. But of course, I don't repeat them here. I write them once. That is A union B. So what that means is that basically the union of two sets A and B, denoted by A union B, contains all those elements which are either in A or in B or in both of them. Meaning that in both, I suppose what they mean by that is basically this part over here, which is practically A intersection B, right? So what that means is that when the sets A and B are two events associated with a sample space, then A union B is the event either A or B or both. So then you can say that when the sets A and B, are two events associated with the sample space, associated with a sample space, then A union B is the event either A either A or B or both. Either A or B or both. Now this event A union B is also called A or B. So this event, basically this event A union B is also called A or B, right? Therefore the event A or B, which is equal to A union B, is the same thing as basically omega, such that omega belongs to A, and or omega belongs to B. Omega belongs to B, right? So now this is the union of two sets. Now there is also some other event, and this is what kind of upside down the way that we think. For example, as you can see over here, what I have written is, probably I should rephrase my sentence over here, or we will look there. But as you can see, I have written over here, Anil will pass the test and Ashima will not pass, right? This is the way that we write a sentence in English. But then, believe it or not, for this kind of situation, you are going to use basically the concept of the union of two sets, and we will find out why in just a few moments, once we have basically dealt with the event A and B, right? So now let's go and let's talk also a little bit about the event A and B, and let's see what we can find over there. So the event A and B. So the event A and B, what that is basically, so we know that the intersection of two sets basically, which is basically the A intersection B, is the set of those elements which are common to both A and B, that is, which belong to both A and B. Meaning that basically if you have this set A over here, and if you have this set B over here, then this part which contains all the elements that are common to both A and B is denoted as A intersection B, right? That is basically what we know from sets. Now, if A and B are two events, then the set A intersection B, if basically let's suppose that A and B are two events. If A and B are two events, then the set A and B, A intersection B, denotes the event A and B. This denotes the event A and B. This denotes the event A and B. So A intersection B denotes the event A and B, right? Thus, you can say that A intersection B is equal to basically all omega, such that omega belongs to basically A, and omega belongs to B. That's how you write this thing. So for example, in the experiment of throwing a dice twice, let A be the event score on the first throw is 6 and B is the event sum of the two scores is at least 11. Then you get basically two sets A and B. We have written this a couple of times before. And so then A intersection B would basically contain two outcomes of this experiment, and then basically the first event was the score on the first throw is 6, and also the second event was the sum of the two scores is at least 11. And then you would get, as a result of that, if you take the intersection of A and B, you would get basically these two outcomes here, 6, 5 and 5, 6. You would get these two over here. And so this set over here, A intersection B, may represent the event. This may represent the event. The score on the first row is 6, and the sum of the scores is at least 11. And the sum of the scores is at least 11, meaning that, I mean, logically, both parts of those that is statement connected with the connective and are true, are necessarily true. Now let's go back over here. Let's go back over here to the exercises and see why they have used the connective Let's see. Okay. So that makes sense. So basically, so we said that the event A and B, that is A intersection B, and the event A or B is basically A union B, right? Now, over here we said that basically either an anneal will pass and basically a schema will not pass, or anneal will not pass and the schema will pass. Now, in order to, so basically then, or is union, right? Or is union. And it does make sense, because otherwise it's not really possible. So there is no need to, I mean, I usually don't do this kind of thing, but I just wanted to memorize it, but it's not really possible. It's not really, I mean, necessary, because when you say basically, when you have A and B over here, let's say you have A and B. So if you write basically A, simply if you write A union B, that would be basically this whole part over here. This whole part over here. So then you can say, instead basically you can describe this situation as A or B, meaning that the element could be found in A or in B. And and it does make sense. On the other hand, if you have some set A over here and some set B over here, and A intersection B it denotes basically this part which is common to both the sets A and B. And of course then you can basically describe the situation as A and B, meaning that if there is some outcome or some element or whatever that is in this shaded area, that means that basically that element belongs to A and also belongs to B. Otherwise it wouldn't be here. So it's very simple, and it does make logical sense. So now let's get back to this problem and solve it. Okay, so now what that means is that now you can write this as, basically I'm using the word and here, so that's basically anneal will pass is, so if I were to rewrite this one more step, I would write it as either basically anneal will pass was the event, anneal will pass was the event E, and a schema will pass was the event F, right? So anneal will pass would be F, and would be F, and basically a schema will not pass. So to use and, basically of course you need to use the intersection concept as we talked about it. And anneal will pass was actually the event E, I suppose. that was the event E. So that is the event E. And so a schema will not pass would be, a schema will pass is F, so that is F prime, right? So either this or basically, or you can say a nil will not pass and a schema will pass. So a nil will not pass would be E prime, and you have an and over here, so you use the intersection, and then the schema will pass would be F. So, and of course you know that these two events are these two events are basically supposed to be mutually exclusive, meaning this excludes the other one excludes the other one. And the reason for that is that so here we have a nil will pass and a schema will not pass, and a nil will not pass and a schema will pass. So well, you know, these two events are just like, for example, now I don't really know why these are exactly mutually exclusive, but we will find out. I mean, that's okay. So I just write it here, but I don't really know why. So where E intersection F prime and basically E prime intersection F are mutually exclusive. And so therefore you can say that P of only one of them will pass. So that therefore you can say that P of only one of them will pass. Is the same thing as P of basically E intersection F prime, or E prime intersection F. That you're calculating the probability of this, which is the same thing as so when you're using or, that means that you can write this as P of, for example, E intersection F prime union with E prime intersection F. And so we said that basically P of A union B is the same thing as P of A plus P of B plus basically P of A intersection minus P of A intersection B minus P of A intersection B. And of course, in case the two events A and B are mutually exclusive, then you don't have to write this part. but I don't really know if that's the case. So what I'm going to do is just I'm just going to leave it in and see what happens. So now I can write based on this A intersection B, right? So what I can do is that I can write this as basically P of E intersection F prime plus P of basically E prime intersection F minus P of basically the intersection of these two events, which is basically the intersection of these two events would be the intersection F prime intersection E prime intersection F Okay, so let's take a look at the Venn diagram and see if how these events are mutually exclusive. So basically the events are E intersection F. So let's say that you have some event E and some event F, right? So you have some event E and some event F. Let's say that this is E and this is F. Now this event, the intersection of, you know that basically F prime, meaning not F, would be basically, and if I call this S for example, then F prime would be this whole thing over here, meaning it would be basically, let me use for example this thing over here and make it a little bit larger. And then the color I'm going to use is basically this color for example, and make the spacing, the hardness for example, something like 50% or so. So basically then this part over here is, this whole part over here is not F, right? This whole part over here, and then if I go back over here and take a look at my pen, so this is F and this is E, and so this whole part over here is F prime or not F. Now the intersection of basically of not F and E is basically this part over here. The intersection of not F, which is this whole part that I have shaded, and E is basically this part over here, which is basically this part over here, which is the same thing as E minus F. So this I can write it as E intersection F not F or F prime is E minus F. Which is basically this part over here. Is basically E minus F, right? Now, E prime, which is not E, on the other hand, would be basically this whole set S except for E, right? And then F is basically, F would be basically this part over here. I'm sorry, F would be this part to this whole part over here. So the intersection of E prime, the intersection of E prime with F would be this part over here, which is F minus E. F minus E. Now the union of these two would simply be the union of now of course you see that these two events, you can see that basically these two events are of course mutually exclusive, because E minus E and F minus E, the intersection of E basically minus F, the intersection of them, F minus E, that is equal to the null set. They have nothing in common. This part is basically F minus E, this part is E minus F, and basically these are analogous to exactly these two basic intersections, which is basically the two events that we want to find the probability of. So I can say that basically these two events are actually mutually exclusive because they have nothing in common. So then based on that, what I can write is that since the two events are mutually exclusive, what I can do is that I can just simply forget about the rest of this and just write basically P of E intersection F prime plus P of basically E prime intersection F, right? Right. So now that I know this, I can simply calculate this. Meaning that so to check whether I haven't made any mistakes. So far we have P of E intersection F prime plus P of E prime intersection with F, which is the same thing as now P of E intersection with F prime. You can write that as P of E I think we had something like, let me see, we had basically P of let me check here, let me see what sort of formula we had for so P of A union B. Okay. Okay, so let me find this formula. I'll be right back. Okay, so I did try different things, but I couldn't figure out how to calculate this thing. So what I'm going to do is that I'm just going to leave this as it is right here, and then we will figure out some way to deal with this thing. Otherwise, I don't really know how they have solved this problem. So now let's basically move on to the to the next example, and we will figure this out in the exercises. We will find something in the exercises. Based on that, we will basically learn this. Now, there is another, so let me keep this over here for the sake of, this is basically layer, this is page 454 here. 454. We will come back to this and we will solve this problem. Okay, so now the next question is the next question is basically a committee of 2 persons is selected from 2 men and 2 women. So a committee of 2 persons or 2 people is selected from 2 men and 2 women. Selected from 2 men and 2 women, right? Now, what is the probability that the committee will have no men, 1 man, and 2 men? What is the probability that the committee has basically no man, A, no man, B, 1 man, and C, 2 men. So to solve this problem, what you want to do is that you want to basically, the total number of people is a committee of 2 people is selected from these people, from 2 men and 2 women, right? So the total number of persons is 2 plus 2 is equal to 4. And out of these 4 people, 2 can be selected in 4 combination 2 different ways. So basically the total number of people is basically you have 2 men and 2 women. The total number of persons or of people is equal to, is basically 2 plus 2, which is equal to 4 people. And out of these 4 people, out of these 4 people, 2 can be selected in 4 combination 2 ways. And in case you're not very familiar with the concept of combination, so let's do a quick review on, let me show you a couple of examples using basically how you use basically the concept of combination, and then we will use this in the rest of this example. Okay, so I was trying to find some way to explain the concept of combination, but well, it's a long story really. So I think what I'm going to do is that I'm going to end this video here right now, and then I'm going to basically go back and do a complete review on combinations, and there is basically something called permutation and combination. And of course you need to be familiar with that, otherwise when we go further, then you will have problems there. Moreover, what I'm going to do is that I'm going to do a little bit of a review on the chapter, basically on the chapter that deal with the algebra on sets and that kind of thing. So now the way that you will be able to use to find these videos is that you do need to basically go into the basically on YouTube. On YouTube, basically you have, if you go to my YouTube channel, you will see basically all of these playlists here. So from this point on, what you need to do is that, so first what I know that I'm going to do is that I'm going to do a chapter on permutation and combination. It's just a review, right? So I will add them somewhere basically on this somewhere along among these playlists. So then you would see basically something like, for example, NCERT Mathematics Class 11, for example, Chapter 7, which is about permutation and combination. Now, once we get to the end of this chapter, then we will decide whether we need to go and do a chapter on sets and the set theory and that sort of thing. If that's the case, then you will find those videos here as well. So then what that means is that before you go to the next video in this playlist, you need to first go and check basically whether those two basically chapters are there on this page. If that's the case, then you would start with permutation and combination. Next you will go to the set theory if I happen to create that, and then you will come back over here and then continue from the next video, because this way we cannot move any further without at least doing permutation and combination. And it's not that complicated. We can get through this permutation probably in a 4 to 5 videos, and then the set theory is not that complicated either. So in the next video, now you know what to do. You need to go and look for permutation and combination, get to the end of permutation and combination. At the end of permutation and combination, I'll tell you whether I will do a review on the set theory or not, and then you will know what to do. So I'll see you in the next video, and thank you.